Hi everyone, today we'll go through these problems, longest palindromic substrings. So given a string S, return the longest palindromic substrings in S. In this case, we can really come up with the example for the S strings. Example 1, we have S having B, A, B, A, and D. The first three characters in here, B, A, B, is the palindromic substrings, and then it is also the longest one. We also have another one is ABA is also the valid answer. I think we can return either one of it. In here we have really short questions, but we also need to ask interviewers some questions to clarify this as well. We can ask the interviewer that string in here cannot be empty, and if it is empty, we can just return the empty strings. Is that right? We can find the answer in here, and it said that S length is equal to 1 or more than 1, and it's smaller than 1000. So it will not be empty, so we don't have to worry about that. We can also say that string is also like one character, so we just return one character because it's also the palindromics, right? And I think that is the right one. So we can also asking whether in here is just all lowercase characters, can it be uppercase or special character or even space. We could find in here S is consists only digit and English letters. So it contains all the lowercase, uppercase as well as also number, but it will not contain special characters or space character. We cover understand the problems, so next step we will go to the planning and matching step. So in here we have example 1, S is equal to A, B, A, A, D. We can see the brute force solution right away is to find all the substrings in this S and then verify it whether that substring is a palindrome or not. But thus, brute force solutions will have the time complexities is big O of n to the cube. So with n cube, this is a huge one. We will need to optimize that solutions. Maybe bring it down to n squared. It's a better choice. With that, we can come up with a solution like whenever we get to a character, we will expand from the left of it and then from the right of it to whether it can form another palindrome substring or not. In here, we can see B and B is the palindrome substrings. With the expanding step in here, we can get the palindrome substring. So with that expands from the center solutions, firstly, we will have to have the start pointers and end pointers, which will help us to forming the substring letters. So at first, the start pointer and end pointer will point to the first characters. And also, we will have to loop those the string S here to finding the current character. So at first the current character is pointed to the first characters is B at index of 0 here. So palindromes we will have two cases. One case is the odd. The length of the palindrome's substring is odd, and case 2 of that is the even characters for their palindrome substrings. With the odd versions, we know that, for example, we have B, A, B in here. We will just have like A is like 1 centers. We just have like 1 centers in the odd case here. But in the even case, for example, B and B in here, we're having 2 centers. If we have A here, we also have 2 centers, which is double B in here. So we know that palindromes will separate into 2 cases, and we will need to check both cases in here. So for that, we know that the current character we are having is B, and we will need to expand from the left and from the right to see if we find another palindrome substring or not. So we will do case 1 first. Case 1 is odd, so we just have 1 center, which is character B in here, the first character B here. And it can expand from the left and from the right, but in the left of B's we don't have anything, so we know that we don't have to expand the right to find the string anymore. We only have like 1 character is considered a palindrome substring in this case. And then in case 2, we will need 2 centers. 1 center we already know is B here, so the next center we're choosing is the next character from B to the right, is A here. So with A and B as the characters, and we know that these 2 centers is not equal from each other. So in here, we know that K2 is only bring up the longest palindrome substring in here is just 1. And with case 1 and case 2, we calculate the maximum length, which in here is a max from case 1 and case 2. And in this case, it will be max from 1 to 1 and it will be equal to 1. So with max length is equal to 1 and the start pointer and end pointer still point to the same characters, we know that is B, so we don't need to update the start pointers and end pointer in here. So next we will move the current pointers here to A. Once get to A, the index is at 1. With A in here, we will have the case 1 and case 2 again. With case 1 in here, it will expand from the left and then the right of center A. The left of center A is B, the right of center A is also B, so we know that it's forming the palindromes. In this case, it's get up to 3. And so case 2, we have one center is A, and then another center we will point to is B. A, B in here is not equal from each other, so the length of case 2 is still 1. And then the max length of this will get updated to 3. Max length is 3, and this is more than the gap between the start pointers and end pointers. And so we know that the end pointer is not pointing to the correct character in here. So we will need to point the end pointers to B here. So we know that the end pointer will point from index 0 to index 2 here. The start pointers will be the same. But how can we calculate the start pointers and end pointer in this case? So the start pointer, we know that it will point from the standards is A in here. So we have index is at 1. And the length of it is 3. And we know that it's forming the palindromes. So we know that there will be one character in the left of the centers and one character at the right of the centers, which is forming the 3 in here. We can see the formula for the start in here would be at the centers is index here. So with the centers is index, we move half of the length here to the left of it. So it will be index minus the max length here. And it will get minus 1 and then divide by 2. Right? Because we have B, A, B in here. And I is at here. And we know the max length in here is 3. And we know that S pointer should be pointed here. The max length in here minus 1, it will be 2. And then divide by 2 is just 1. So the index here is minus 1, it will point to actually the B in here. So we know that it will work. And then the end pointer in here, we will point to the right here. So we will have index plus something. We can also have the half of max length, right? So the max length divided by 2. So in here, we're forming the formula for to get the start pointers and then the end pointers. We can update the end pointer in here to 2. And we keep doing that. We will get the longest palindrome substrings. So we can see it clear in the implement step. In this step, I would do it in Java, but I also have Python solutions in the description below, so please check it out if you're familiar with that more. So firstly, we'll have to have the start here is at 0. This will represent the start pointers, and then the end pointers is at 0 as well. And then we will have to loop through everything. So with I is at 0. I is smaller than the S length here. And then I++. So once we loop through, we have to explore 2 cases. So with here, I will do case 1. With case 1 in here, we will calling it another functions is expand from centers. Expand from center here. So with expand from centers, we will pass in the length of string S, the index of the centers we want, which is i's and then I in here. This one is case of odd. And then in here we have case 2. We also calling another method is expand from centers and pass in same string S. And in here with the even case, the first center is the I we have, and then another center is I plus 1. So in here we have the even case. Once we have 2 cases, we will calculate the max length of it. So the max length of it will be my.max from case 1 and case 2. After we have the max length, we will see if we need to update the start pointer and end pointer or not. So if max length is more than the end pointer, the gap between the end pointer and start pointer, we will update the start like the formulas we export in the matching step. So I.length -1 and then divide by 2. We're cutting the half of the max length. Right in here it should be max length. Okay, n is I plus the max length in here divided by 2. Okay, once we have that, we can clearly return the S substring in here, and we already stored the index for the substring is the start and then the end here. We want it to be inclusive, so we plus 1 here. Next part, we will need to implement these functions. So as we'll return integers, calling these functions, and we will pass in string s and the index of the left and right. Okay. So in here, we expand from the centers. We will have the left and then the right. Firstly, we will have a while loop. We will check if the left is larger or equal to 0, because it needs to be in the range of s in order to make it a substring. So, both of it will have to valid. In here, we also have to make sure that the character at the left and then the character at the right is equal to each other. So in here, we're checking, because this is the palindrome, so the character at the left and character at the right need to be equal from each other. So once we have that, we know that it is still the palindrome, and we need to expand the left and then the right. The left will do minus, because from the centers we go to the left, and then the right need to plus here, because we go to the right of the center. In here, we just need to return the gap between the left and then the right. This is the length of the longest palindrome substrings we have. So in here, we have to have the right minus the left and do -1 as well. So once we do have that, we finish all of this implementation step. Let's test this out to make sure everything works. And because in the interview settings, you don't have the IDE like this, so we need to do it by hand. So in here, we have example 1. So we will have the start and end is at 0, and then the end is at 0 as well. And moreover, we have I in here is also 0. Next, we will calculate the case 1 and case 2 in here. So case 1 would be doing this, and we have I in here is 0 and then 0. And with this, we can come to these functions. So the left is 0, so it's come to this statement. The left and right is valid, and then the left and right is equal for each other, since it's part of the same characters. And so it will expand the left and then the right. So in here, the left is -1, so it will be -1. And then the right, let's get up to 1, so it will be 1 in this case. So from it, we know that the left is not valid anymore, so we get to the return statement. With this return statement, we have the right minus the left here, 1 minus the -1, so it will be 2, and -1. So this part will do return 1. We still need to calculate the case 2 here. We're having exactly the same case. This part, the next centers would be 1, but the length in here, the left in here and the right is valid, but the character at the left side and character at the right side is A and B, which is not equal from each other here, so we return right away. So in here, the right of it is 1 minus 0 and then -1. So in here we do return 0. And from that, we have the max length is 1. And with max length is 1, it's larger from the end and then the start, the gap between the end and start. So it will get update the end and start here. The start will be the same because 0 minus the 1 minus 1 here, it will be 0. So 0 minus 0 is still 0. So this part, we still have the start is 0, and then the end, this would be 1 minus divided by 2 is 0, and then 0 plus 0 is still 0. So the end and start point is still the same, point to 0. Next part, we will have to calculate the case 1 and case 2 again. So like this, we will having the expand here. This will not be 0 anymore, but this will be 1, because I is updated by 1 here. With 1 and 1, we know that the left and then the right is valid, and then the substring here is also equal for each other. So it's expand from the left and then the right. For that, the left in here is now 0, and then the right is 2. Left at the 2 and 0 here is still valid in this part, and the character of that index is equal for each other. It's still point to character B. So it is valid, so it's keep minus the left, so let's do -1 here, and then the right is get to 3. And with that, we know that the left is no longer valid, so we return it. So in this part, it will get to return 3. And in case 2 in here, I just get updated to 1, and then this part is get updated to 2. With this, the left and the right is still valid, but the character at the left and then the right is not equal for each other. One pointer to the A, and then another pointer to B. So we just return right away in here, so it's still 0 in this case. Okay, so the max length here get updated 3. So we know that the max length here is larger than the gap between the start and then the end. So we will need to update the start and end. Start is still part to the same because 2 divided by 2 is 1, and I in here is 1. 1 minus 1 is 0, so start is still 0. And in here, max length is 3. 3 divided by 2 is 1, and then 1 plus 1 is 2. So n in here is a 2. And if we're still doing this, it will kind of like getting to the latest substrings we have. In here, if we continue, it will getting the result string is ABA, which is still the longest substrings. To make sure everything is working, I just run the code here. Now we check if this fully works. Okay, we have all the test case accepted. So in here, we will have the time complexities of these solutions would be big of O of n squared. So because we have the for loop here to go through every character inside the S, string S, and also the while loop here is also expand from the center, so it will be of n squared. With that, we also have the space complexity. In here, we don't store anything, we just store pointers. That one, we have the space complexity is of 1, constant space. So to make sure this works, just submit it. So as we can see in here, we have successfully resolved here. This one is faster than 96% of all Java submission for these problems. Please like and subscribe to my channel. If you have any questions, please comment below. I will get through it. And thank you.